Imagine the universe whispering its secrets in a language only a select few can understand. This is the essence of cryptography, the art of encoding messages to make them incomprehensible to anyone without the proper key. From ancient ciphers to modern encryption algorithms, the human desire to protect information has driven centuries of innovation. In an increasingly interconnected world, cryptography plays a crucial role in safeguarding our privacy and security. Whether we're sending emails, making online transactions, or accessing sensitive data, encryption acts as an invisible shield, protecting our information from prying eyes. Without cryptography, the digital world as we know it would be incredibly vulnerable, open to eavesdropping and manipulation. Just as the vastness of space is held together by fundamental forces, so too is our digital world secured by the power of cryptography. It's a silent guardian, working tirelessly behind the scenes to ensure that our communications remain private and our data remains safe. From the simplest substitution ciphers to the complexity of modern encryption algorithms, the goal remains the same: to keep our secrets secret and to ensure that only those with the right key can unlock the secrets that lie within. As computers emerged from the realm of theory into practical tools, the need for robust encryption methods became increasingly apparent. The 1970s witnessed a surge in digital communication, and with it, a growing awareness of the vulnerabilities inherent in transmitting sensitive information electronically. Governments and organizations alike recognized the need for a standardized encryption method, one that could be widely adopted and trusted to secure sensitive data. This need led to the birth of the Data Encryption Standard, or DES. Developed by IBM in the early 1970s, DES was a groundbreaking achievement in cryptography. It was a symmetric key algorithm, meaning that the same key was used for both encryption and decryption. This approach simplified the encryption process, making it more practical for widespread use. In 1977, DES was adopted as a federal standard by the National Bureau of Standards, now known as the National Institute of Standards and Technology. This adoption marked a significant milestone in the history of cryptography, establishing DES as the go-to encryption standard for decades to come. While the inner workings of DES might seem daunting at first, its underlying principles are surprisingly elegant. Imagine a complex dance between bits, carefully choreographed through a series of substitutions and permutations. This intricate ballet is the essence of DES. The algorithm operates on blocks of 64 bits, scrambling them through 16 rounds of complex mathematical operations. Each round involves a combination of substitutions, where bits are replaced according to predefined tables, and permutations, where the order of bits is rearranged. The key to DES's strength lies in its use of a 56-bit key. This key, which is also a string of zeros and ones, dictates the specific substitutions and permutations performed in each round. Without the correct key, deciphering the encrypted message becomes an incredibly complex puzzle, virtually impossible to solve through brute force. The combination of substitutions, permutations, and a secret key makes DES a formidable encryption algorithm. It's like a masterfully crafted safe, where each dial and tumbler represents a different mathematical operation, and only the correct combination can unlock its secrets. The impact of DES on our digital lives is profound, even though its presence is often unseen. It's the silent guardian protecting our financial transactions, securing our passwords, and safeguarding sensitive data across various industries. One of the most well-known applications of DES was in ATMs. When you withdraw money from an ATM, DES works behind the scenes to encrypt your PIN and protect your account information as it travels between the ATM and the bank's servers. DES has also been widely used to protect passwords. When you create a password on a website or application, it's often encrypted using DES or a similar algorithm before being stored on the server. This encryption ensures that even if the server is compromised, your password remains protected. Beyond ATMs and passwords, DES has found applications in various fields, including database encryption, protecting sensitive information stored in databases, virtual private networks, creating secure connections over public networks, and file encryption, safeguarding confidential files stored on computers and servers. These are just a few examples of how DES has shaped our digital world, quietly working in the background to protect our information and keep our online interactions secure.